Hi, my name is Leandro Facchinetti, and in this video I'm going to do a code review of a project of mine. It's at liafac HTML. It's a project that I covered in my previous video in this channel, and it's a TypeScript / JavaScript library for working with HTML right in the JavaScript code. It's using tag template literals from JavaScript, so that you can interpolate variables and they will be safely scaped, and you can even interpolate arrays and they will be concatenated. So if you want to know more about how the library works and what you can do with it, go watch the previous video. I cover in depth how it works and why I think it's a good idea to do HTML this way. And in this video, I'm going to cover the implementation of how this library works. It's relatively straightforward, but it brings together two ideas that I really enjoy. The idea of using tagged template literals as a bridge between different languages in JavaScript, and this very simple idea of making things safe by default by escaping everything and using libraries to do this escaping, because there are libraries that solve this problem, which turns out to be a relatively complex problem, and they just solve the problem the right way, and we can use that instead of trying to come up with our own bespoke way of encoding HTML entities. Anyway, so let's jump right into the code. I'm going to first talk about the implementation of the library itself, and then I'm going to go over the tests and the configuration for GitHub Actions, which is used to run the tests and to deploy this as an NPM package. I'll briefly cover the configuration I'm using for TypeScript and the configuration I'm using for the package itself. So to begin with, this is the implementation of the library. It's a library with one function, and this function is simple. It fits on the screen almost. And I think that this implementation it's a really nice and simple thing, and yet I think it's super powerful in the way that you can use it. And I wrote this code so that it's easy to understand. At least that was the intent of how I wrote it. So let's see if you find it easy to understand or not. So first things in this are importing libraries to do two different things. This one is to encode HTML entities. That's what the name stands for, HTML entities. I think that's what the name stands for. So if your HTML has things like quotes and brackets like that, then you need to escape those using entities that look like something like this. And that's what this library does. And it's not doing just the simple characters you would expect, like quotes and brackets, but it's also doing things like Unicode code points for things in the, what is it called, the transcendental region of Unicode. Anyway, it's doing the right thing in terms of escaping HTML entities, and that's what we're gonna use. And then there is this other one that cleans up your strings, and this was necessary in a project that I also covered in this channel, both in a code review and also in another video in which I show how to deploy the project. It's called Kill the Newsletter, and it transforms emails into atom feeds. So it's not exactly HTML, it's XML, but it's also using this library to build XML. And the problem is that people are sending emails with lots of weird characters out there. And this includes characters like a backspace character that's usually written this way. It's usually written in this way. In JavaScript, it's written this way. And I suppose that if I go to the console and I write something like hi, and then backspace, hello, and I console log that, you can see that it literally means type the word hi and then backspace, hello. And that's why it prints just hello. So this is a weird character. It's a control character, And it's definitely not supposed to be in XML. I also don't think there is any good reason for this to be in HTML in general. So I thought it would be nice to just use this library that's sanitizing XML characters. This library is solving a complex problem. This library is solving a relatively simpler problem. It is more or less just a library with a regular expression, but this regular expression has been taken from the RFC, or I don't know, the specification for XML. I don't think it's an RFC. Anyway, it is taken from the specification for XML, and it does the right thing. It gets rid of all characters that are invalid in XML. And if you have a string like hi, backspace, backspace, hello, it will clean these control characters, which I think is the right thing to do. It will just not put spaces there. It will just get rid of the characters, and this is what your string will look like. So I don't think that this is like perfect. You may not want to lose these characters, but it's definitely safe. The output will always be just characters that are valid in XML. And I would argue that there is no better thing you can do, at least in the context of Kill the Newsletter, but I think that in most contexts, there is nothing better you can do. You get rid of the junk and you render whatever else is left. Now, there is this export default here, and that's because I would like people to be able to use this library by just saying, like, for example here, just import HTML from, and in this case I am in the test, so I'm importing from dot to import the index file, but in general, people who install the package would use it like this. And I wanted that to be the way you use the package. You can also, if you want, use this type alias. So if you are in TypeScript and you want to declare a variable not just as a string, but as HTML string, then I suppose that I should do that right here, right? That's the good thing about doing a code review. You always find something that you would like to improve. So this is a way of saying it's not only a string, it's HTML, and maybe in the future this library evolves in some way that changes this. I don't think it will. Anyway, if you want to do that, then you can use it like this. So this library has both a default export as well as named exports. So this is a default export, and these are named exports. One for the HTML function that is a tagged template literal, and one for HTML capital HTML that is a type. It's literally just a string. And the way you use this is, for instance, like this. So you can write your HTML just by tagging the template literal, and if you want, you can escape and go back to JavaScript and evaluate any kind of expression. In this case, it's literally just my name, but you could do any sort of variable lookups and any sort of computation in here. You know how tag template literals work, I suppose. If you're watching this, I suppose that you know about this. So what you may have never done is to implement one of these. You may have used them, maybe by using my package or by using some other packages that do de-indentation. Dedent is a famous package that does de-indentation of template literals. There are plenty of libraries like that. You may have used them, but you may have not implemented one of these functions. So let's look at how this works. When you do this, what effectively you are doing is calling a function, right? So let's take this case that is more interesting because there is here interpolation. So this is a function call. And the way this function call works out is that it is going to pass you two arguments, or actually in this case 2 arguments. In general, a variable number of arguments. The first argument is a list. And this list contains all the parts of the tag template literal. So it is this, and then there is an interpolation here, so it skips over that and gives you this as well. Then for the second argument on, it is the interpolations. So if you have just one, it looks like this. If you had multiple interpolations, so maybe if you had another one right here, another one right here, if you had one of these, then it would be an extra argument. So you may note that the first one is a list, It's an array in JavaScript, but the rest are literal arguments. They are not a list. They are not in an array like this. No, they are just a variable number of arguments. And in fact, this one is not even really a list. It is this other thing called a template strings array. And the reason why this is different from just a regular array is that it doesn't only contain this list, this template strings array acts as a list. So if you want to treat it as an array, that works. But if you're interested not in this strings, but in the raw strings that a person wrote, then you have access to that as well as part of the raw argument. So here I'm calling the template strings array, which is this. I'm calling this in my function template. So if I want, I can treat template as just a list or a regular array. I can do things like map, or I can use the template raw, which again is an array. I can do things like map. So what is the difference between template and template raw? Well, it has to do with backslashes. If you do something like \n, then this is treated as a new line. I showed you before how \b is treated as backspace. So these are characters that have special meaning. If you use just template like this, and that's what we do in this function, if you just use the template variable like this, then you get things like new lines and backspaces. You get those characters that are the new line and the backspace. On the other hand, if you use template raw, which we don't use in this function, but if you use template raw, then what you get is literally a backslash and then literally the letter N. You may, if you want, in your code, interpret that as a new line. But that's up to you. You get literally what the person wrote here. And in our case, we are working with HTML, which is a language in which backslash has no special meaning. So I thought it would be better to just treat the backslash as a constructor for escaping, for things like new line, if you wanted to write your string like that. If you, on the other hand, you are not working with HTML, but you are working, for instance, and I guess that's the classic example of this, if you're working with LaTeX, then in LaTeX, backslash has some special meaning. It is the thing that you use to use macros in LaTeX. So, for instance, you do things like this in LaTeX. And you don't want this to be treated as a tab, as it would here. You want this to be literally backslash text boldface. So to make this happen, if you were to implement a function to a tag template leader for LaTeX, you would probably do it with LaTeX template arguments. This is a variable number of arguments, and then you would use template raw, and then do things like map or filter or iterate over the template raw, whatever. In any case, that's why this variable is not simply a list or an array of strings. It's this template strings array, which is something that comes with TypeScript. You don't have to import this from anywhere. It's just a type that is available to you. And now you know the difference between raw and what they call cooked strings in the context of tagged template literals. So let's revert all the changes we made here and get back to the implementation. So as you have seen in the LaTeX example and here as well, we receive two arguments. One is the template, which is the array of parts of the tag template literal, and then the substitutions. These are the interpolations. So in this case, for instance, here, this is just this, right? My name as one argument. So this substitutions is an array with one element, which is my name, at least in this case that we are calling right here. So how are we going to use the template and the substitutions? Well, we are going to do two passes over them. The first one is up to here, and the second one is up to there. On the first pass, we are going to call our sanitization library to get rid of all the characters like backspaces. So we are going to call this sanitization library and get rid of all the characters that are not valid in XML. So that's one thing we are going to do in this first pass. And another thing we are going to do in this first pass is to treat this problem, or not really a problem, but to treat this case of array interpolation. So in my HTML library, if you pass an array of elements, I concatenate the array for you. Instead of just calling to string in the array, instead of doing that, I join the array for you. So I effectively say this. So you don't have to say this, because it's very common for you to have an array here. Because it's common for you to have things like, suppose you have a variable names, and then you do some mapping, and then you have a name, and then you do some interpolation here, and I guess you would at this point do safe interpolation. So if you didn't watch my previous video, this is the syntax I copied from another library to mean this is a safe interpolation. You don't need to re-escape these characters. They have already been escaped. So in this case, with p element, I guess you would do something like a span in here and then interpolate the name. So it's a common thing to have an array like this, and it's a common thing for you to map over the array, and then you end up with an array. And typically you would have to come and join the array, which is annoying. So in my library, if you pass me an array, I know that you mean to concatenate everything, and that's what I do. I concatenate the things for you. So on this first pass, the one that is highlighted right here, I am going to sanitize all the strings, and I am going to convert if you did not. So the way I handle this case is, if you passed me an array, it goes through untouched on this first pass. But if you pass me just a single argument, like for instance in the case that we were looking at before here, this is not an array, this is just a single argument, then I convert it into an array with a single element. And the reason why I do that is that, so on the second pass, I told you that there would be two passes. On the second pass, I don't have to worry about whether this is an array or a standalone value, because they have been normalized. They are all arrays now. Okay, so that's the purpose of the first pass. The second pass has the purpose of detecting whether you are doing safe interpolation or not. So as I mentioned, safe interpolation means I have already escaped this, so you don't have to escape again. And that's the notation that I'm using. And this notation is not something that comes with JavaScript. This is kind of a hack. This is going to be one of the strings that is passed as the template variable. So it's literally just a string that ends in $. So I have to look, do I have a string that ends in $? If so, I have to remove the $, because the $, is part of the syntax. It's not part of the output. So I remove the $, and I do something different in the treatment of these values. I treat them as safe. So I don't call the library to escape the characters because they are considered safe. Okay, so let's go over how these two passes were. Oh, and of course, on the second pass, I also smoosh everything together and I form one big string that is going to be my output. Okay, so let's look at the two passes in detail. First pass, so I'm going to iterate over the template. As I said, it's an array or a list of parts. So when I say part, I mean this is a part and that is another part. So these are strings, and I'm iterating over them. I'm not using raw. I'm using the cooked strings, and I'm mapping over them. And on which one of the parts I'm calling the library that sanitizes. And these are my template parts sanitized. Nothing too fancy there. The substitution sanitized is going to do a similar thing. It's going to take the substitutions and it's going to map over them. The substitution is as an array, and I'm going to do some things. I'm going to call the sanitize library, but before I even do that, I have to call string, which is a function in JavaScript. And I have to call this function to tell that I want this to be converted into a string. I guess suppose it's equivalent to calling to a string on the substitution part, but this function is guaranteed to return me a string. And that's necessary because in some cases you may be passing things like numbers. And I suppose I have an example here. Yeah, here you're passing null. So if you are interpolating something that is not an array, I convert to a string. Sorry, if I are interpolating something that is not a string and not an array, if it's an array, then it has that special meaning I already mentioned. If it's a string, then if it's a string, it goes through. If it's not a string, it's converted to a string using the string function. Then I call sanitized. And then I'm mapping over, so yeah, here I'm mapping over all the pieces. So if I have multiple arguments, I'm mapping over all of them and I'm doing this. But remember that my substitutions, they may be arrays, right? So for instance, we were looking at this case here where the substitution is an array itself. And as I said, we want to normalize this so that even if your substitution is not an array, even if you're in this case, now what I want to do effectively is just wrap this in an array so that later I can consider that all things are always arrays. So what I do is I check, is my substitution an array? If so, let it pass through. If not, wrap it in an array. And then, so the first thing I do is this. So the first thing I do is, do I need to wrap this in an array? If so, wrap it in an array. And then right after that, map converting into a string and sanitizing. So even if you have an array where one of the things, so let me find the example here. So in this example, if I had something like this, it doesn't matter because I'm first converting things into an array and then I'm mapping over the array and converting everything to a string first and then sanitizing using that escape sanitize XML characters library. And then there is this line. This line is super interesting. Remember the example I gave you before where I was translating this into a call, a method call or a function call, a more normal function call. So your template parts would be these strings. And then the substitution is just this, in this case. Note how we have two template parts and just one substitution. And that makes sense because we have a string. You can think of this template literal as a string that you are slicing. And in each one of these slices, you are putting in one of the substitutions. Well, if you slice 3 times, you end up with 4 parts. If you slice 4 times, you end up with 5 parts, and so on. So there is always one substitution less than the number of template parts. If I have 10 template parts, I will have 9 substitutions. That makes sense. But for the second pass, it is for this pass. It makes a lot more sense to me in the way that I think about things and in the way that I wrote this library. It makes more sense to me if instead of having 4 parts and 3 substitutions, if I had 4 parts and 4 substitutions, so that I can just wrap them, like zip is the name of this function. It just zips together and matches like this. Cute little hand diagram here. So what it's doing is just taking one part of the template, one part of the substitution, one part of the template, one part of the substitution, and zipping these two arrays together. For me to be able to do this, I have to put what I call a sentinel. I have to put this dummy element at the end, because in the end here, there is no substitution. So you can think of this part right here, right after the string ends. There is no other substitution here at the end. But what I do is just I put here a dummy argument, like suppose that the function was called this way. Now we have a matching number of template parts and substitutions. And I can just zip very naturally. The code doesn't have any special case. Am I on the last substitution? Oh, if so, don't put the substitution here because it's not that. Don't have to worry about it. The sentinel is here to take care of this case. It's another way of thinking about this. I find it a more natural way, so I put this as a last element. And remember that we have normalized all our elements are now arrays. So my last element must be an array as well. And with that, we have prepared all the substitutions and they are ready to be zipped into the template parts to form the output. So that's what we are going to do here on this second pass. We have prepared the template parts by sanitizing. We have prepared the substitution by normalizing into an array and by mapping to sanitize, to convert into strings. We have put the sentinel in place. The first part is over. On the second phase, what we are going to do is again go over the two arrays, this time the sanitized versions. And we are going to zip, so we are going to put everything in one big HTML output. And we are also going to take care of the $sign at the end of the template part that represents safe interpolation. So we are going to take care of this character here, meaning don't encode again because this has already been encoded. So let's go through this. The way I'm doing this is with a buffer. So what I'm going to do is for each one of these sections, so each one of the substitutions and each one of the template parts, they're going to go as one element in this buffer. At the end, as you can see here, that's what's happening. This is pushing into that buffer. At the end, I'm going to join the buffer with the empty string. And that's what, at the end of the day, does the thing I was mentioning before. So I was showing you how if you pass a list, my library is going to do this, right? I showed you this before, and this is where I'm doing it. Why do I do it this way? I could do instead something like a buffer is an empty string, and anytime I want to put one more thing in there, I just add to the end of the string, so something like this, and probably some more code here. And at the end, I wouldn't even need to join. That works, but it's relatively slower because to build a string is, I haven't measured this, I have not benchmarked this, but this is true of other languages like Lua, and I suppose it's true of JavaScript as well. To add the strings together, what JavaScript has to do is to copy over the existing string. So suppose that you have a big template, thousands of parts, thousands of substitutions, and then you are building everything together. So you end up with big strings and you add more and more things to the string and you end up building more and more, bigger and bigger strings. So if your template starts with ABC and then you would have to add D, E, F, and then maybe this. So if you have something that will amount to this, right? If you did this using the thing I just showed you, adding strings together, you would do computation that looks like this. In that case, JavaScript would have to build this string, this intermediary string, then to finally be able to build the final output. And it would have to do that for all intermediary strings. So if you have thousands of parts, it would have to build thousands of intermediary strings, and they are only going to grow bigger. The problem is, at least in some other languages, I think it's true of JavaScript, I haven't measured. It should never do that, but I also think it's conceptually cleaner to do with a buffer. Anyway, the point here being, to build these strings, it costs a lot. because it's not just a matter of building a new data structure and putting the existing strings into the new lists. It has to literally go over and copy this region of memory into here, and then copy another region of memory into here, and this, it costs more. So you are better off putting everything in a list so the strings are still the same. You would end up with lists that have strings A, B, C, D, E, F, and so on. You would have lists like this, but the strings themselves, they never change. So the strings themselves, the things that cost more to build, remain the same, and then you are just pushing more and more things into an array. And sometimes JavaScript may have to allocate more space into that list, which is something that you don't have to care about, but JavaScript will have to allocate that space for you. But that does not cost as much as building new strings. Also, I would argue that having a buffer is conceptually cleaner. You are building something, so you add things to the buffer, and then later when you're done, you join all the pieces. Okay, so that's the structure. We start with an empty buffer, we push things along the way, and then we are gonna join everything together at the end. And we know that we are pushing template parts and then substitutions, template part and then the list of substitutions. So let's go over how this works. We have the template part here and the substitution, and we need to traverse these two arrays in lockstep. They need to be traversed in tandem. So we don't want to loop over one of the arrays and then loop over the other, because that, if you have the two arrays here, that would be take one of the elements, loop, take one of the elements, loop. If you nested two loops, if you had something like two loops over here, that's what would end up happening. So in this one, you would be traversing the templates, and in this one, the substitutions. If you did something like this, you would be traversing one of the arrays many times. That's not what we want. We want to traverse the arrays in sync. So the way we do this is, instead of traversing the array directly, we traverse the array keys. And we have already done the previous work here of making sure that both arrays have exactly the same size. So they are prepared to be traversed this way. So we just look at the keys, the indices of this array. So we look at the template part sanitized, and we get the template part, and the same for the substitution. And here we are grabbing the keys. So the index is one of the keys. It starts with 0 and grows. Next, I need to check, is my template part ending with $? That's the magic value that does safe interpolation. So for instance, in this case, this would be my template part. Does it end with $? Yes, it does. So in that case, what I'm gonna do is I'm going to take out $, right? Because it means do safe interpolation. It's not part of the output, it's part of the syntax. So this $sign here needs to go away. And the way I'm doing this is by modifying this variable, the template part. So in this case, I am building a new string, and there is no way around that, because the buffer here was just putting strings that existed together, but this one needs to modify the string. Strings in JavaScript are immutable, but I need to modify it by creating a new one without the $. And the way I do this is by calling slice from the beginning of the string. -1 represents the second to last element. So the second to last element will be included in the string, but everything else will be excluded from the string. So you can think of this as the string that we are considering. The template part is this string, and 0 is this position, and then this is position -1, this is position -2, and so forth. You can count from the end, and you need to keep in mind that the last character is not inclusive. This range is non-inclusive, so it will drop the last character. So -1 means take this part of the string. Effectively, that's what the slice is doing. and then I assign to the same variable. So I'm not changing the variable because strings in JavaScript are immutable. I'm not changing the variable. What I'm doing is just assigning to the variable this new string. If my template part ended with $, I get rid of the $. If my template part did not end in $, it means that I need to escape the substitutions. So the substitutions here are not safe to interpolate if I don't have the $, which is the case, for instance, in this line right here. I have some HTML. I do an interpolation right away. In fact, I don't even have anything around it. Okay, so maybe this one is a better example. So here I have a paragraph, and then I do something that is not a safe interpolation. So in this case, there are no $2, no, just one. This is not safe interpolation, so what I need to do is to escape all the characters in the middle of this string. So I need to escape the substitution. What I do to escape the substitution is, remember that at this point the substitution is a list, it's an array, because, for instance, this is an array right here, and we converted stuff into an array right there. So this is an array. So we loop over the array, we map over the array, and for each one of the parts, we call our library that does the HTML encoding of the substitution part. And then we end up with substitution. So note how in the first pass here, we did the cleanup. We sanitized removing characters that are not valid XML. That we already did, and that we did unconditionally. There is no way for you to signal that you don't want sanitization to happen. Sanitization always happens. You always sanitize, you get rid of all the invalid characters. That is, if you're using this library, you are going to produce valid HTML. There is no way around that. But then the encoding is optional. I mean, you are producing HTML, it's always valid HTML. It may have cross-site scripting, and you may be doing unsafe stuff if you decide that you want to use the safe interpolation operator with something that is not actually safe. You will end up with HTML that is vulnerable to cross-site scripting. Remember that default is safe, but if you want to do the unsafe thing and you're not careful, then you will end up with HTML that suffers from cross-site scripting, but at least it will not have characters that are invalid. So it's always valid HTML. So the only thing you can control with the $sign is whether you encode the HTML entities or not, or in other words, whether you consider that substitution to be safe or unsafe. By default, you consider it to be unsafe, which ironically is a safer default because you don't have to think twice to get the safe behavior. Okay, so that's simple. Substitution is just mapped, and again, I cannot really change the substitutions, but I can map over them and then do the encoding. Well, I suppose in this case I could change this. I could loop over this and literally change the elements in there. It doesn't really matter all that much. I'm just mapping and creating a new list. So what I'm saying here is I could do instead is for I of substitution keys, substitution at I equals that. Oh yeah, like so. So this would change the array in place, and here I am mapping, which creates a new array. I don't think it's a big deal. I'm sure that JavaScript will optimize this somehow, I suppose. I don't know. Maybe that could be made faster. And then I push everything into the buffer. So the buffer is a list, it's an array, and it expects, push expects all the strings you want to push into the array. So I push the template part first, and then all the pieces of substitution. So substitution is an array itself, but I use this operator to just splice the array in place, and they become arguments to push. So at the end, if you had arguments that looked like, and I guess this is the third time I'm doing this. So if you started with arguments like this, then on the first pass, after having, okay, I'm going to copy this into the other file so we can look at this as it progresses. So you have your arguments here, your template is this, your substitution is that. So after this first pass, it will be, the substitutions will have been converted into a list. At this point, they will have been converted into a list, and there will be a sentinel here, and this is going to be the template, or at least the sanitized version of it, and this is going to be the substitutions. And they will have been sanitized by calling this. And at this point, they will have been joined together into the buffer. So the buffer will have each one of the template parts, and then right after each one of the substitutions, in sync. So you can see me sort of tracing how this is going to go. So this is the first loop, and then the second time it loops around, it's going to push the template, and then the substitution parts, which in this case it's literally nothing, so it doesn't push anything. It gets to this point where it has exhausted all the template parts and substitutions, so the buffer looks like this. You join it together and you end up with the HTML result. That's the story. That's how this function works. Now let's take a look at how the tests work. There's nothing too fancy here. It's using Jest, and in each test I describe what the case is and what the output should be. The way I literally wrote the tests was, I think that I implemented the library first because I sort of knew what I wanted the library to do, and then I came up with all the cases first to, of course, test, and I did get some mistakes using the tests, but more importantly, this documents precisely, even better than the README, which is just a lot of words, this describes precisely what the library does, because it's executable. But the way I wrote this is, at this point I already had the library. I just wanted to write some tests to make sure that the library was doing what it's supposed to. So what I did is I just came up with the test cases for all the special cases I had already thought about. And then I used Jest's two-matching line snapshot, so it looks like this. And I just call the two-match inline snapshot. And if you don't know this trick, it's super cool. When you run the tests, it's going to run the tests using Jest, and it's going to take the output of this part, and it's going to paste here. So now what I'm doing is not writing what I expect the output to be. What I do is just call the function that I have already implemented. So that's very much not a test-driven approach. It's more of a check-driven approach. I just made that up. It's tests after the implementation. So I just look at the output and I say, is this what I want? Yeah, it is. So it stays. And the next time I run these tests, if something is different, then suppose that I change this and now the output will be different, and now this test will fail. I really like this idea of inline snapshots. So the test has failed. I really like this idea of the match inline snapshot because I can think about what I want the output to be just by looking at it, and if I'm happy, I move on. I don't have to write all the outputs I expect from all the tests, and in many cases it's faster to just use this matching line snapshot. That's what I did for the whole library, and there are cases with interpolation, interpolation being escaped and doing the right thing, and if you want to try to double encode stuff, then it will double encode. There is no way to detect that something has already been escaped and try to prevent double encoding. The way you prevent double encoding is by using the library the right way. So for instance here you would say that this has already been sanitized, so that's what you do. You mark that interpolation as safe. And then there are tests for things like, do I coerce things into a script, into a string? Do I treat safe interpolation right? And what about safe interpolation that I want to escape? That's it's a weird edge case, but what if you wanted to have literally a $sign before your interpolation? Well, the way you do that is by interpolating with a $sign. So arrays are joined, and arrays by default will also escape. So if you have here in the middle of your array something that is unsafe, the default is to escape. And I think that's one of the main differences between this library and one of the existing libraries in this space. There are other libraries, of course, that do HTML templates using tagged template literals. And I guess the most popular one does not do safe interpolation of arrays by default. It does of single variables, but not of arrays. It was one of the motivations for me to create this library in the first place. And then, some more test cases here, array with safe interpolation. So if you are marking this as safe, I don't encode. That works for standalone and also for arrays. And then the invalid XML characters, we just remove them. So in this case, I have here a long example where I try to interpolate the backspace in all the ways I can. So before any interpolation, after any interpolation, interpolation with just a variable, with safe interpolation, with an array, with safe interpolation of an array, all of them go away because I have properly called, sanitized in both the template as well as on the substitutions, so they all just go away because backspace is not a valid character in XML. And I had to mark this as ignore for prettier, which is a library that does formatting of code, because otherwise it would get rid of my backslashes here. When formatting, it gets rid of the backslashes B because it knows that this is invalid HTML. So if you're using prettier, you are already safe against this because prettier will get rid of the \b for you. I am using prettier to format my code, but I wanted this to stand because this is the purpose of my test. So I marked this as prettier ignore. That's all there is to the tests. Now let's move on to the configuration for GitHub Actions. I think this is a pretty straightforward. It's a simple implementation here. What GitHub Actions does is every time I'm pushing to GitHub, it will run some jobs. One of the jobs tests. It will run my tests in Windows, Mac OS, and Ubuntu, both on Node 14 and 15, because those are the two versions that are the latest versions, the long-term support and the bleeding edge in terms of the latest version. And I think it's a good practice to run my tests in all operating systems. Sometimes there are some weird edge cases that only come up in one of the operating systems. And then I run the tests. So check out the repository, set up Node with the proper Node version that comes here from this variable, and then run install CI test, which does install in CI mode. So it takes in account my package.json. And then runs the tests right after that. So it's one nice npm command that does installation and testing. So it was designed to work with continuous integration servers like this. Now, if all my tests have passed, and this is a tag, so this is not just master or feature branch, this is a tag. So if this is a tag and my tests have passed, then I'm going to run on Ubuntu. It doesn't really matter. I could do this on Mac OS. I could do this on Windows, but I do this on Ubuntu. What I'm going to do is using the latest Node version of Node, just because it doesn't really matter all that much, but I prefer to use the latest. And using this registry, what I'm going to do is install using CI again, taking into account package lock, and it's going to publish to npm. And I need to set up a secret that is my key for npm. I do that using the GitHub graphical user interface. I click around and I set up a secret in the repository settings. And this way, anytime I push to GitHub to a tag, it deploys, or not really deploys, it publishes to NPM. And the way I do this is I usually say NPM version, and then, for instance, patch, if this is just a patch release. So if I'm, for instance, now I think that the version is 3.0.0. So if I want to release 3.0.1, I use patch. Otherwise, if I want to release 3.1.0, I do npm version minor. Or if I want to release 4.0.0, I do npm version major. That will create a tag that I can just push to GitHub, and it will give me a new version right in npm. I never publish stuff from my own machine. I always publish from GitHub, because then I know that all my tests have passed and everything. Let's talk about my TypeScript configuration now. The TypeScript configuration is just, I have a source directory and I want to output to a lib directory. I'm targeting this version of JavaScript, which is not the bleeding edge, not the latest, so it's supported in Node 14 as well. I am using common.js because some of the libraries that are going to use this one are still stuck in common.js, though with Node 16 coming up in a couple of days, really, we will have a LTS version of Node that has proper support for ECMAScript modules, so maybe this will go away in the near future, and so will this. And I think that ES module interop is necessary for things like this to work, because here I'm using a default import for HTML entities. I want to produce declaration files, declaration maps, and source maps. So when I run tsc to compile my project, it looks at all the files in the source directory, compiles all of them into the lib directory, but it also puts there the declaration files. So it puts the JavaScript, the declaration files, and the source maps, so that everything will be linked. So if you're using this project, my liafac HTML project, in your own project that is also in TypeScript, you can click on things, go to declarations, go to the source, the implementation of stuff, everything just maps correctly. And strict, because I want to have warnings or really compilation errors when I do things like forget to treat something that could be null, that sort of thing. For the package file, this is all stuff that comes with npm init. So if you just run npm init, you'll have a template for the name, the version, description. Main is what you import. So if you just import liafac HTML, this is the file that you end up importing. This is the types. So this is a TypeScript specific thing in package.json. If your repository is on GitHub, you can just say what is after the github.com/ here in the repository key. Some keywords, my name, license, but this one is kind of tricky. If your package is scoped in npm, and that means it has an at something before the name, so at your name / something, then you need to have this, because by default, packages that are scoped are private. But I wanted this to be public, so I had to add this key. Then I run prettier as part of my tests, and then I run jest. To prepare, it is something that runs before, well, it's saying right here, it is running right before the package is published. So when I am running npm install ci test, it will run not really here, it will run this as well here when it installs, but more importantly, when it publishes, it runs tsc to compile and produce for instance, the main file, the types, and so forth. So it will literally do the thing I just did in the terminal, which is to call npx tsc. When it's about to publish to npm, it does that. When you install npm install, it does this as well. These are my dependencies. We looked at these before, my dev dependencies. So I set up the types for the libraries I need, the types for Node.js, the types. I don't think that this is strictly necessary in this project. It's just a good measure. I suppose that this project works just fine in the browser, though I haven't tested. And then the types for jest itself, prettier because I am calling it in my tests, tsjest to run my tests that have that have TypeScript. So this is the configuration for jest using TypeScript. TypeScript itself, so these are the configurations for jest. I am just interested in running things that are in the root directory, that is the source. Specifically, I want to ignore everything in lib. I'm using the tsjest preset, which sets up jest to understand TypeScript. In my test environment is Node, though again, I think that this would work in the browser just fine. Just haven't used it in the browser. And that is it. That is the implementation of the whole library. That's all there is to this library. It's relatively simple, but at the same time, it's tagged template literals in JavaScript, and I just cannot get enough of them. I really think they are it's a feature that I have not seen in any other popular programming language. It is something that you see in some academic and smaller programming languages, but having this in JavaScript is just such a treat and one of my favorite features. So I'm really happy that I have this small library to take advantage of tagged template literals. Anyway, thanks for watching this. If you find this kind of thing useful, make sure you subscribe to the channel because I always have more of these videos coming up. And I do have libraries that are using tagged template literals to do CSS and SQLite, so look forward to that. Make sure you subscribe to the channel to get the notifications and everything. And also you can support my work on Patreon, on PayPal, find the links below. Thanks for watching this one. I hope you liked it. I see you on the next one. Bye.